All right, so I've done the first 10 on your pretest in a different video. This is starting with number 11 on your pretest. So it has absolute value of x minus 5 plus 2. Remember, absolute values are v's. If it's negative in front, it's an upside down v. This is always backwards of the sign inside of the parentheses, or absolute values or square roots. Whatever it is, it's always backwards of that sign, where that point is. So my point is going to be at 5, 2. The one outside is always the same. So I come here to 5, 2. Because it opens upwards and there's no number in front of here, I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. And since it's a V, I do the same thing on this side. Okay, absolute values are always positive, so it can't have, they're both going to go the same direction. Okay, now because it is a less than, it's going to be dotted. Okay, not a solid line. So it's going to be dotted line. And because it's less than, it's shaded underneath. So it's going to be shaded underneath. Because the y values under here are smaller than the ones above the line. Okay, so anyways, everything's shaded underneath. I think you probably got the idea by now. It's all shaded under here. Missed a spot there. All right, missed a few down there. We'll call that good. Got the general idea. Now we need to graph the other one. So this says y is greater than x minus 3 minus 6. So again, remember the point is 3, negative 6. It's always backwards of in here. So I go 3 down here to negative 6. I put a dot there. Now the numbers in front of here, there's nothing written, so that means I go up 1 over 1. So I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I think when I made this, I had intended for this equation to go down, but it didn't happen. So, but it works out all right. You can still learn stuff from my mistakes. So anyways, draw this graph. There it is. It's a dotted line as well. And it says greater than, so it's shaded above. Okay, so it's shaded above that. So it'd be everything above this line. So it's everything that was above the line. Now I look at this, my answer actually is the place where those two intersect. Okay, so my actual answer, I wanted that to be on highlighter, is where those lines, where the shades intersect. So this stuff in here, that's my actual answer, because that's where both, any point on inside of this area would work for both of these. Okay, so this picture is your answer. This is saying anything in this shaded region. So if you're using a pencil and you wanted to erase all of this shading stuff, if you wanted to erase all of this stuff out here, might have just froze my screen. Makes it look pretty bad, but anyways, with the highlighter, it doesn't work so well. If you wanted to erase this stuff out here, you could erase this stuff out here and leave only this part shaded, or you could have the double lines and that will work as well. That's all I need for your answer, is just to have this stuff in here shaded twice or something, and you should, maybe if you wanted to write on there, this is the answer area or something like that. So whatever you want to do on that part. Okay, so the next one has three equations. Y equals negative 1/3 x minus 3 squared plus 6. So I go to my calculator, I go to y equals. I'll show you how to do it by hand as well. Negative 1 divided by 3. So I type that in. Parentheses x minus 3 squared plus 6. Graph. So the center of this should be at positive 3, 6. So positive 3, 6, there it is. I hit second graph and look at a few points. At 0, it's at 3, 6, 3, 3, 6. So that gives me an idea of where things are. So 6, 3, or 3, 6, I mean. So that's one point. 0, 3, 6, 3, 0, 3, 6, 3. That's another one. Okay, if you want to go to your calculator, you can find another one. Negative 3, negative 6. 9, negative 6. So negative 3, negative 6. 9, negative 6. Okay? So anyways, the center again is the same as what it was for the absolute values, 3, 6. And so that's how I knew where those were. Then to get these points a little bit harder, you can use a table and just start plugging numbers in. That'll generate some points for you. So again, this is going to be a dotted one. Cruise on up here. So there's my upside down parabola. It's a less than, so it's shaded underneath. So it's shaded in here. Now I graph this one. Y is less than x plus 3. That means I come to 3 on my y-axis, and I go up 1 over 1, up 1 over 1, up 1 over 1. So it looks like this. And it's a dotted line as well because it's a less than. So dotted line. Now this one, I start at paused. Oh yeah, we got to shade this. So it says it's less than. So that's below the line. So it's everything shaded below the line. Okay, so that includes everything in there. But so far, the only place where they intersect is in here. So now we're to this line. I start at positive 3. Now I go down 1 over 1 because that's the slope. So down 1 over 1. Down 1 over 1. Down 1 over 1. Down 1 over 1. Get the idea. Again, it's dotted as well. You're supposed to hit the dots. Okay, and it says greater than. So it's shading everything that's greater than. There we go. So it's all of this area. So the only place where they all intersect is this piece. So that's your answer, is this area right here. That's where all of them intersect. So this is your answer area. Any point inside of here, if I plugged it into these, would make this equation where y is bigger, this equation y would be less than, this equation y would be less than. So any point in here, that point, if I plug that in for all of them, 4, 4, or 5, 3, you know, that would work for all of these. Yep, 3 is less than 8. If I plug that in here, I'd get an answer out here, and 3 is going to be less than that. I plugged it in here, negative 5 plus 3 is negative 2. Yep, 3 is bigger than negative 2. So any point in this shaded area, if I plug that into any of those three, will be a true statement. All right, number 13, it says bonus. So I go to my calculator. We're going to graph a square root. So it says y is less than the square root of x minus 1. So y, oh, you're supposed to change those. So on yours, you move it over to the left. You can bring up a full rectangle. You'd hit enter. That way you could change your line. Okay, it could be, there's one in the middle here that's going to change greater than, less than, whatever. Mine doesn't allow me to do it, so I can't. So I have to just graph it as it is. So square root x minus 1. Graph. So there it is. It starts at 1. I hit second table. That's going to give me some points. So at 1 it's 0. At 2 it's 1. So I'm going to come here. At 1 it's 0. 2 it's 1. Another point. 5 it's 2. At 10 it's 3. So at 5 it's 2. At 10 it's 3. This is a dotted line because it has a less than. So there it is. Now it says less than, so it's shaded below. And it's only this area that's shaded below. Because there's no graph to the left of that, so it's only this area that's being shaded. Okay? So that gives you a general idea of what's happening with that one. Now we're going to go to the calculate and graph the next one. Has a negative in here, that's the only difference. So I'm going to hit second insert. Above the delete it says inserts, that's why I hit second delete, because it inserts. A negative x, and right here we're going to put a plus 1. Could have just probably typed it in. But anyways, that's going to show up now. Here's this graph. It starts right here. I hit second graph. It's going to give me some numbers. Errors everywhere that way. So at negative 8, it's 3. At negative 8, it's 3. At negative 3, it's 2. At negative 3, it's 2. At 0, it's 1. And it started right here. Dotted line again. Oh, that's not good. Not sure that's much better, but anyways, we'll pretend it is. So there it is. It's less than again, so it's shaded below. So I messed up on my ideas with this. Um, I wanted really both of these to be shaded together at the same time, but they won't be, so there's really not an intersection. But now for the last part, we're going to draw this ellipse. Remember, this is the center. It's always backwards of the signs inside the parentheses. So my center is at 1, backwards of that, -1. So x is 1, y is -1. So that's my center. In the x direction, you go the square root of this. So I go 3 each direction. In the y direction, square root of 16 is 4, so I go 4 from my center each direction. So now it's an ellipse. So, and it's a equal to, so that's going to be a solid line. It's going to be kind of curved. Again, you can use Desmos to get the full view of this. And there it is. Because it's less than, I shade inside. So then I get this visual. So there's not a place where all three of them intersect. In my head when I made it, it was supposed to have been this area right in here. Get a little heart. But anyways, that's not what it really is because they all don't meet there. So there really is no solution. There's not a point where all three of these cross. So there's not a real solution that would work for all three of these equations. Anyways, that was what I was supposed to do on that for that bonus. Okay, now on the next page, I'm not going to do all of these, but I will do some of them. On 3-58, it says that says your math class wants to collect money for a field trip, so it decides to sell 2 kinds of bags of candy: the chocolate lover's bag, and then it describes what's in it, and the combusting caramel bag, and it describes what's in it and how much it costs. So the chocolate lovers cost $4.25. There's 5 chocolate truffles and 2 caramel turtles. The combusting caramel costs $3.50. There's 8 caramel turtles and 10 chocolate truffles. So anyways, that's what we have. Wants to know how much each truffle costs and how much each caramel turtle costs. So what we're going to do is we're going to create an equation. From this first one, the chocolate lovers, I know there's 5. These both have the same letters, so let's just call this one chocolate and 2 caramels, and that makes $4.25. This one has 8. Let's keep them in the same order. Has 2 chocolate and 8 caramel, and it makes $3.50. So I have 2 equations, 2 unknowns. Now what I'm going to do is eliminate something. I could make these turn into 10 because 5 and 2 both go into 10, or I could make this top one turn into 8. So I'm just going to make it go into this turn into 8, and it needs to be a negative so that they cancel out. So I'm going to multiply all this one by -4. So -4 times 5 is -20 chocolate. -4 times 2 makes -8 caramel. And -4 times 425 is 17, but in case you're curious, 425 times 4 is 17, and it's going to be negative because I forgot the -4 on that. Equals -17. My other equation did not change, so that's still 2 chocolate plus 8 caramel equals $3.50. So now 20 negative plus 2 makes -18 chocolate. These go away, and I'm going to have -17 plus $3.50. So -17 plus $3.50, and I get -13.5. So now to solve this, I divide each side by -18. So I go back to my calculator and I hit divide by -18. And it tells me that those cost 75 cents each. So chocolates equals 75 cents. So now I can plug that back into either of these 2 originals. So I'm going to go 2 chocolates plus 8 caramels equals $3.50. But I know that the chocolates are 75 cents. So I'm going to have 2 times 0.75 plus 8 caramels equals 350. So 75 cents, if I have 2 of those, that makes $1.50. Plus 8 caramels equals 350. So I minus the 150 over here, minus the $1.50 from over here. 8 caramels equals $2. So I divide that by 8. So the caramels cost, if you're curious, 50 cents. 2 divided by 8, quarter, there we go, not 50. 0.25. So 4 quarters makes $1. 8 quarters would be $2. So anyways, messed up in my head what I was thinking. But there we go. So caramels are 25 cents. Chocolates are 75 cents. So I could get more candy for buying the caramels, but you just don't get as much chocolate that way. All right, the next question. Down at the bottom, it has some problems. I decided I could do this one graphing. You could do it using a system of equations. I could replace this y up here and put them equal to each other. Okay, so you could do this. But then when you work out this part, remember the squared means I'd have x minus 4 times x minus 4. So I have to distribute here. So I'd have x squared minus 4x minus 4x plus 16, and that's in parentheses because there's a negative 3 in front of it. Negative 2. Then I'd have negative 4/7 x plus 4 still over here. So now I'd have to distribute that negative 3. So I'd have negative 3x squared. These two combine to be negative 8x. So negative 3 times negative 8 is a positive 24x. 3 times 16 is 48, just to make sure. So that would be a negative 48 minus 2. We would still have this stuff over here. So then on this side I could combine like terms. So 48 and 2 make negative 50. So anyways, I'd get to this point, and then I'd minus this 4. I need it to be equal to 0. And I'd add 4/7 x to this. So I'd have negative 3x squared plus 24 and 4/7 x minus 54. Then you have to deal with this seventh stuff in the middle equals 0, and you'd have to factor or use the quadratic formula. So anyways, I decided just to graph it because I thought that might be easier. So I'm going to start at plus 4. I'm going to go down 4/7. So if I did the same thing, 4, 1, 2, 3, 4, 5, 6, 7. So that's still down 4/7. Connect my dots. Maybe I'm going to connect my dots. Connect my dots. So there's that one. If you want to get your points by using the calculator, you can come to your calculator and hit y equals. Clear this off. Type in negative 3 parentheses x minus 4 squared minus 2. Hit graph. Now you can see your picture. It's going to go to the right 4, down 2, and then turn upside down. So if I hit second graph, it's going to give me some points. They're not looking so good, but they are points. And get to a few more values that seem more manageable. So there's some values that work a little better. So 4, negative 2. And then 3 and 5 are both negative 5. So 3 and 5. So I'm getting the idea that these lines never intersect. 6 and 2 are negative 14. So I'm not sure at which point I hit the pause button on the record, so I might have missed out on some. But anyways, if I look at my graph on this, see that they never cross, so I get no solution. If I would have tried to work this out to get an x answer out of this, it would have come out to be negative inside the square root, so that would have been no solution on that. So anyways, that's what that means. If they never intersect, there's no solution that works for both of these. So on the next problem, it said x plus y equals 0. I decided to solve for y, so I minus the x. And then I decided I might as well try to graph that. So I'm going to come here and I'm going to make a little graph. So I hurried and did that. So y equals negative x, that means I start in the dead center. So start at 0, 0, because there's no y-intercept out here. So I start at 0, 0, I go down 1 over 1, down 1 over 1. So I do that all the way down. Okay. Connect my dots. Should have used a ruler. Anyways, you get the general idea. Now this next one, it's going to have a vertex of 4, negative 6. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. I should write that here. That's a 6, that's a 4. 1, 2, 3, so that somebody else walking along, if they only saw the picture, they'd be like, oh, they're counting by ones. Okay, so now if I go to my calculator, I can type this in. X minus 4 squared minus 6. Second graph, it's going to give me my table. So I see right here is where my numbers start like mirroring each other. So at 0, it's up to 10. 2, 4, 6, 8, 10. At 1, it's at 3. 2, it's negative 2. So 1, it's at 3. 2, it's at negative 2. At 3, it's at negative 5. And then it's just the same over here. It's a symmetrical. So there's that one. That one's going to be up here. So now if I connect those dots, I get the parabola. And it intersects right here and right here. So the intersection point is 5, negative 5. So x equals 5 and y equals negative 5. And the other one is when x equals 2, y equals negative 2. It doesn't always work out that way. It just happened to on this one. So I write those down, and that's my answer on that. Okay, the next question says, it's a story problem. It's on the number 19. So adult tickets for Mr. Moose's Fantasy Show on Ice are $6.50, while a child's ticket are $2.50. Tuesday night, there were 453 total in attendance. They collected $1,667.50. How many adult tickets and how many children tickets? So what we have is we have adult tickets plus children tickets, and we sold 453 of them. We have $6.50 per adult. We don't know how many adults there were, but we know we charged $6.50. And for children, we had $2.50. We don't know how many of those, but we know in total dollars we got $1,667.50. So now it's just an elimination process. I'm going to multiply all this by negative 250. So I get negative 2.5a minus 2.5c $453 times 2.5 is 1,132. 1,132.50 cents. So now I can use my elimination process. Those go away. 6 minus 2 is 4. The 50s go away. So 4a equals, so that number minus, oh, I better do it the right way. So 1667.5 minus my answer from above is 535. Now that doesn't sound quite right because I shouldn't get a decimal. If I divide that by 4, I get 133.75. So something doesn't look quite right. Let me hurry and check out some math. Found an error. I don't know if that's the only error, but I wrote down 453, but it should have been 435. So when I multiplied that by 250, 2.5 times 435 is 108.7.5. So 108.7.5, and that's a negative. So 1667.5 minus, so I get 580. So 580 divided by 4, this I think is going to be better, 145. We don't have to worry about like 3/4 of an adult walking in. We have a full adult walking in. So I now know adults plus children equals 435. I know the adults are 145. So I minus the 145 from each side. So 435 minus 145. 435 minus 145, 290. I could have done that by hand. 5 minus 5 is 0. Borrow 10 from there, put it here. 13 minus 4 is 9. 3 minus 1 is 2. So anyways, there are 145 adults and 290 children. All right, last problem that I'm going to do on this. The rest of it's extra credit. So let's talk about this last one. It says there's going to be 50 questions. Some are 3 points, some are 6. Okay, I'm just going to call these X and these Y to make it easier for me. So I know that X questions plus Y questions, so the 3-point questions and the 6-point questions, there are a total of 50 of them. Okay, the X ones are worth 3 points. The Y ones are worth 6 points, and there are a total of 195 points on this test. This isn't true for your test, by the way. So now I have 2 equations, 2 unknowns. I'm going to just multiply all this by negative 3 so that I can eliminate the x's. I could have multiplied it by negative 6 and got rid of the y's, but I decided to go by 3. So I combine these. The x's go away. 6 minus 3 is 3. 195 minus 150 is 45. Divide that by 3, and I get that y equals 15. Well, x plus y equal 50. And I know that y is 15. So I plug 15 in for y. Now I minus the 15. X equals 35. So the 3-point questions, there's 35 of them. The 6-point questions, there are only 15 of them.